Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Good morning, everyone. Today we will examine athletic performance enhancement with a focus on training methods and the physiological adaptations that underpin improved performance. My aim is to link specific training interventions to measurable changes in physiology and to show how coaches design programs to target those changes for different events. First, I will discuss endurance training. Traditional high-volume, steady-state training increases capillarization, mitochondrial density, and stroke volume. These changes raise aerobic capacity. More recently, high-intensity interval training, or HIIT, has been used to elicit rapid increases in VO2 max and mitochondrial enzymes. Short bouts at near maximal intensity followed by recovery stimulate both peripheral and central adaptations. Tempo runs and threshold training specifically elevate the lactate threshold. Raising lactate threshold allows athletes to sustain a higher fraction of VO2 max for longer periods. I mention lactate threshold because it is a more sensitive predictor of endurance performance than VO2 max for trained athletes. Now turning to strength and power. Resistance training produces muscle hypertrophy and increases myofibrillar density. Neural adaptations, such as improved motor unit recruitment and firing rate, improve the rate of force development. Plyometric training complements resistance work by enhancing stretch reflexes and elastic energy storage in tendons. The combination often yields larger gains in sprint speed and jump height than either method alone. For instance, a 400-meter runner will prioritize anaerobic capacity and power over long, steady distance runs. That athlete needs repeated high-intensity efforts and rapid force production. Periodization is the systematic manipulation of training volume and intensity across phases. A typical macro cycle alternates base building, specific preparation, competition sharpening, and tapering to maximize performance at key events. Tapering reduces training volume while maintaining intensity. Physiologically, it allows restoration of muscle glycogen, rebalancing of hormones, and recovery of neuromuscular function so athletes peak on competition day. Environmental strategies can also enhance performance. Altitude or hypoxic training stimulates erythropoiesis, which increases red blood cell mass and hemoglobin concentration, and thus oxygen-carrying capacity. However, the response to altitude varies. Some athletes gain substantial hematological advantages, while others show little change, so monitoring is essential. Recovery modalities are integral to enhancement. Sleep, nutrition, and active recovery affect protein synthesis and hormonal milieu. Without adequate recovery, the beneficial adaptations from training will be blunted or reversed. A practical case study illustrates these principles. An elite cyclist used polarized training. He performed many low-intensity aerobic rides, plus 2 or 3 high-intensity sessions per week. Over 6 months, his mitochondrial density and lactate threshold improved, and his time trial power at threshold increased measurably. Another case is a sprinter who combined heavy resistance lifts twice weekly with plyometrics and sprint technique sessions. Neural drive improved, and sprint times fell as rate of force development increased. Finally, I will emphasize testing and individualization. Regular physiological testing such as VO2 max, lactate threshold, and strength profiling allows coaches to tailor programs. Individual response to the same training stimulus can be quite different. In summary, targeted training methods create predictable physiological adaptations. Understanding which adaptations matter for a given sport allows practitioners to design efficient training plans that enhance athletic performance. Thank you. We will now discuss questions and how to plan a periodized microcycle for a hypothetical athlete.
Listen again to part of the lecture, then answer the question.
I mention lactate threshold because it is a more sensitive predictor of endurance performance than VO2 max for trained athletes.
This concludes the listening section. For more TOEFL practice tests and study materials, visit Spinta.org.